In this video, we are going to create movement systems for a top-down game as well as a platformer game. By the end of this video, you will understand velocity, move and slide, top-down movements, gravity, and jumping. Let's start creating a character. So the first thing we would do is go to other nodes and we would select the CharacterBody2D node, which is most commonly used node in Godot, as it is used for enemies, players, and NPCs. CharacterBody2D isn't special because movement is possible. It is special because it provides complete movement framework. It already understands concepts like floors, walls, ceilings, slopes, and moving platforms. We'll gradually explore these systems throughout this series. Now let's make the player visible. Click add child and I'll add a sprite 2D node and then I'll assign a texture to it. Once the texture is attached, you can see the sprite is visible. We also need to add a collision shape to it, as CharacterBody2D requires collision shape to participate in the physics. For now, I'd create a rectangle shape and give it a size approximately equal to our panda. We have our player setup now, so I've renamed the player as player, the character body node. Then I would add a script. I would say player.gd and I would add some code to it. So I have a constant speed and then I have a method called physics process. It basically runs many times a second for every physics frame. The value delta is basically how much time has passed since the last frame was run. Velocity is an inbuilt property of CharacterBody2D, so I am setting its value in x direction as speed, and move and slide is an inbuilt method from CharacterBody2D which helps to move our character based on this velocity that we are providing. If I run it, you can see it moves horizontally with a constant speed. I can also set the velocity so that it would move in y direction as well. So just copy it, paste it. Now you can see I have a separate x and y components and both of the values are speed, so it should move diagonally. So it's working. Similarly, you can tweak these values and you can move the player constantly if you want. Also, you may notice that we are already providing it velocity, so why do we need this move and slide? So if I remove it and I try to play again, it doesn't move because even though the variables are present, the movement and the collision logics are all handled by this method, move and slide. Now let's build a proper top-down controller. So for now, I would remove velocity from here and I would replace it with a method called input.getVector. So it basically takes a negative x, negative y, and positive y as an input. So each input signifies a certain direction. So based on the input we are giving, it calculates which direction we want to move. As for the inputs we are giving, you can go to the project settings, input maps, and you can see all the available inputs that we have. Then I would set the velocity as something like direction into speed. And now if I run the scene, I can control my character using the arrow keys. So if I press up, it's going up. If I press whatever direction of arrow keys, it moves in that direction. This is perfect for RPGs, puzzle games, and top-down adventures. So till now, the player was moving comfortably as a top-down sprite. Now let's look at some platformer movement. To do that, I would need to create another scene. So I would create a new scene, let's say platformer demo. Now that I have the scene created, I would add my player node into it. So you can see the button here which is instantiate child scene. I can click here and I can select my player node. You can see the player scene is now part of our platformer demo scene as well. Now I would add one more thing which is required for platformer, which is the platform which it stands on. So I would add a child node. I would add a static body 2D. We would be learning about this as well in later videos, but for now you can follow along. I would add a sprite 2D to it and collision to it. So I would pull a sprite into it, adjust the sprite size, place it here, then add a collision shape, and we have a scene ready. So if I run the scene, nothing special would happen as we just have our panda and a platform. Move it, you can see it collides with our platform. If I move the platform a bit up, you would be able to see it better. What I'd also do is bring the player down so player appears in the front. And if I play the scene again, you can see I can move the panda and it collides with our platform. I can even collide it from the side, from here, as far as our collisions are present. Okay, so that's how the collision works for character body 2D. But now I want a platformer. I don't want the panda to be moving freely in the air. So if you think about it, platformers generally have a velocity on x-axis and we use a jump button to jump it. So I would replace this get vector with something like get axis, and we would keep just left and right because up and down are not necessary. We just need a jump later. The velocity would be velocity.x because we are only providing x direction of the velocity using the inputs. And if I would have run the scene, I can move it left and right. I cannot move it up and down anymore because I am only setting the velocity.x right now. Now that it's a platformer, the first thing we need is gravity. So I would define a constant gravity. You can try to make it realistic, but realistic values don't often feel so good in the game. So I'm keeping the gravity value a bit high to something like 3000. You can try and experiment with your values. Now we have the gravity. So we want the gravity to work if not is on floor. So basically if our panda is not on the floor, then this method should run. This f block should run. So velocity.y plus equal to gravity into delta. If I run the scene now, you can see the panda fell. To make it more clear, I would just move the panda a bit up, and if I run the scene again, you can see the panda is falling down. You might have noticed that we set the velocity of x directly as direction into speed, but for velocity we are doing velocity plus equal to gravity. Why are we doing this? Why are we not just doing equal to? If I do equal to, you can see the panda is falling at a steady state. That's not really how gravity works. So a downwards velocity usually increases when we are falling down. So to stimulate that, we are doing plus equal to gravity. And we are multiplying it by delta because we don't want it to drastically affect once. So if I do just this and run it, you can see it instantly came down because the physics process runs many times a second. And if I reduce the value to something like 3, you can see it's still dropping properly. But it wouldn't be consistent across the devices if I don't use delta, which ensures that the net result of this would be same across all the devices with all frame rates. Now since we have gravity, let's add a jump as well. I would add a constant jump force. Notice I'm using a negative value for jump force. This is because in Godot, negative moves upwards. So to simply get the idea of this, you can go to the scene area and you can see this grid lines on the left side and on the top. So on the top is the x-axis, and if you see it goes from 0 to positive side if I go on the right, and negative side if I go to the left. And for y, upwards is negative and downwards is positive. Go back to the script again. Now I want, so input if the action UI accept is pressed, which is spacebar for now configured, which is configured as spacebar in input maps, and if it is on floor, I want the velocity of y equal to jump force. So if I run this now, you can see I can move horizontally still, and if I press spacebar, it jumps. So I already have a decent enough platformer already ready. We have actually built two different controllers today, a top-down controller and a platformer controller, both powered by the same character 2D node. Today we learned the foundation of character body 2D, the velocity, move and slide, top-down movement, gravity, and jumping. But Character Body 2D can do much more. In the next video, we'll explore how Character Body understands floors, walls, ceilings, and why motion mode changes the moment behaves. If you're following along, let me know if you have any questions and what you would like to see next. See you in the next one.